Okay, awesome. So we've had some wonderful talks here, especially in this afternoon. We had some amazing keynotes. Learning about that black hole was just, and all the work that went into it. But the part that I really took away the most from that was just how amazing that large team was and how much she respected the fact that, teamwork makes the dream work, which is actually a Databricks principle that we live by. So I just really loved that. It really put me in a good mood. And so a really good mood to talk with you all here today about simplifying and scaling data engineering pipelines with Delta Lake. So first, I'm going to talk about me, introduce myself, but I just want to get to know all of you first. So how many of you have heard about Delta? Just raise of hands. Okay, good, awesome. You probably heard that in the first keynote that we had with Michael Ambrose, which was also very amazing. And how many data engineers do we have in the room? Good, this talk is for you. And data scientists? Okay, good showing. You're welcome to. You will, you will learn something from this too, and you'll learn a lot of empathy for your data engineers if you didn't have it already. But let's talk about me here for a second. So I am a solutions architect at Databricks. I have my master's in computer science that I got from Santa Clara, which is a university in the Bay Area. I live in California. I'm actually a California native. I was born there, which is a very rare thing to meet someone who's actually been born in California. Not to mention my parents were also born in California, so that's doubly rare. But I also have a BS in biology from the University of Washington, and I've worked at quite a few different companies in the Bay Area, HP, Teradata, DataStax, and a small startup called Ingestion, which was actually the enterprise version of an Apache project. It was a project called Apache Trifodian, which is SQL on Hadoop. So before Hadoop died, we needed SQL to be able to use it. And so this is actually one of those projects out of the actually many different projects that were attempting to do that. So I was a PMC on that project and also a committer. So long and short of it, I've worked on 5 different distributed databases. I never dreamed as a little girl that distributed databases and distributed systems would become my passion, but it has. So that's awesome, and that's why I'm here with you all today. And I also I helped create a course on data engineering with Udacity. So let's just go over the high level of what we're going to talk about today. So we're going to talk about the data engineer's nightmares and also their dreams. Then we're going to talk about the data lifecycle versus the Delta lifecycle. I'm going to show you how you can transition your data pipelines to Delta and how your dreams are going to come true because of Delta. Then we're going to walk through a really thorough demo where I'm going to show you actually all the things like high level that I'm talking about. I'm going to prove to you how we can actually do it. And then I'm going to show you how to use Delta. So this is really the data engineer's journey. This is something, it's all well-worn path for all you data engineers, but let's just talk about it at a high level, right? So at first, you have a lot of events coming into Kafka. You may have 2 Spark streams. One's getting written to a table, and then Spark is going through a batch process, doing some ETL on it, maybe putting in another table. And then you have another Spark stream, and it's also putting it, going to a table, writing there, and that's getting ready to do some AI and reporting. Okay, that all seems pretty simple. No big deal so far. Okay, well, but then I also need to do, on my batch jobs, I need to do some reprocessing. My data is getting compacted every hour. I need to do some updates and some merges. Okay, it's starting to get a little bit more complicated. Okay, but now it's starting to journey into a nightmare, because now how am I going to validate that my streams have a unified view of this data, right? And how am I going to do updates and merges with this complex data lake? How am I going to do all this? So can't this be simplified? So what's the data engineer's dream? What are we hoping for? So we're hoping for a very simplified pipeline. We want to be able to process data continuously and incrementally as new data arrives in a cost-efficient way without having to choose between just doing batch or just doing streaming. So what's missing? What's missing here in the middle between what we had and what we want? So a couple of things. We want the ability to read consistent data while the data is actually being written. We want the ability to read incrementally from a large table with good throughput. Of course, we want to be able to roll back in case of really bad writes. We want the ability to replay historical data along with new data that's arrived. And we want the ability to handle late arriving data without having to delay downstream processing. These are all the things that we would hope for and that are missing with our old architecture. So what is the answer? So combining the power of structured streaming and Delta Lake, we'll get the Delta architecture. So we're going to have unified batch and streaming with a continuous data flow model. We're going to have infinite, I'm going to put infinite with a star, of course, infinite retention to replay and reprocess historical events as needed, and an independent, elastic way to scale. So, of course, let's try that architecture with Delta Lake instead. So you may have seen this slide previously. So this is kind of the idea that Delta Lake allows you to incrementally improve the quality of your data until it's ready for consumption. So we're going to have our bronze tables, our silver tables, and our gold tables. And we're going to talk about what each one of those really means here in more detail. But we imagine we're having streams that are connecting these tables and moving the data quality towards those gold level tables. So we're going for the gold here. So with our bronze tables, we're really looking at raw ingestion. This is our raw data. Our silver, it's going to be filtered, cleaned, augmented. And then our gold. So this is our business level aggregates. These are our features that are now ready for AI and reporting, streaming analysis, etc. So what does this kind of remind us of? Remind us of in the past. So this kind of reminds us of the data lifecycle of the past. So we can get, this is just a rough analogy, right? So bear with me here. But we can kind of imagine in the past that with our raw ingestion, that would really be our data lake or our data swamp, right? We just had everything dumped into one place. Then we're imagining we're going to use a different technology to do that filtering, that cleaning, and that augmentation. We're probably going to use something like Apache Spark. And then from there, once we've used Apache Spark for our silver tables, right, we're going to move that into maybe some kind of EDW, some kind of data warehouse, or even a NoSQL database, somewhere where it's going to live at the end. But what if we could just do this whole process with just one set of technology, right? So let's transition from that data lifecycle to the Delta Lake lifestyle. So in this case, what we're going to imagine, now again, I've actually had some questions in the booth about Delta Lake and these bronze and silver and gold tables. Now just think of these aren't actual, this is just an abstract layer of a best practice that you should be doing with your data. It's not necessarily, there isn't like create bronze table, and we'll see that here with the demo. So with our bronze table, like I said before, this is all the raw ingestion. It's going to be a dumping ground for all that data. It's often going to have years of retention. So it's going to have lots of years of data within these particular set of tables. And you want to avoid any error-prone processing here. It's just all going to come in. So then next with our silver, so again, it's going to be filtered, it's going to be cleaned. It's going to be this intermediate data that has had some cleanup applied to it. So it's going to be very easy to query this table for easy debugging. So you're going to be able, you've only done one hop, you're going to be able to figure out what you've done with that raw table, the filtering that you've done, and then now to the silver. And then our gold. So this is our clean data. So while our silver table is, we're able to query that, we are especially able to use the gold table for streaming analytics and AI. So it's that perfect layer that's ready for doing machine learning. It has our features. It also has our business level aggregates. So it's clean data, it's ready for consumption. And you can read it with Apache Spark, or I know coming soon, Presto. So like I said before, the streams are moving the data through the data lake. So we really want those low latency streams that can be either manually triggered or automatically triggered. And it kind of eliminates this need for a lot of scheduled jobs because you have these low latency streams. So, and then just kind of some things, just at a high level to think about with each one of these various table types. So when you think about your bronze table, you really think about what's happening there. What DMLs are happening on this particular table? You're going to think about inserts and updates, right? As that data is streaming into that raw ingestion, that data lake there. Then from there, we're going to go to our silver. So we're going to imagine we're going to have a couple of things there. Probably some deletes. And then as we move to our gold, not only are we going to have the ability to do merge, but also we're going to have the ability to do overwrites. So Delta Lake supports these batch jobs and all these standard DMLs. And like I'm going to show you here in a bit with the demo, with the deletes, that's very important for GDPR, but it's also important for CCPA, which is the California standard of that's coming out very soon. And the ability to do upserts, which we couldn't really do before. And these types of DMLs are things that other EDWs have had for quite some time, but now that you can do utilizing Delta. So we kind of already talked about, now, I mean, you can do deletes along the whole way, but when we talk about that raw ingestion, you just want to have all your data there. Now you can do deletes on them if you wanted, but the more of the idea would be able to do those deletes on the silver and the gold. So it's really easy to recompute when your business logic changes, and you can go ahead and clear those tables and restart the streams. So how the dream actually becomes true. So now it's time for the demo. So this is a live demo, so everybody be kind. Okay, so I hope that's, okay, good, that's a good size. All right, so what can we do with Delta Lake? And so I say, what can't we do? So just at a high level, just to mention, even though everybody raised their hand that they'd heard of Delta, I just want to go over the high level things that Delta does. It adds transactions to your data lake. It adds schema enforcement on your data lake. Also allows for schema evolution, time travel, which data versioning, updates and deletes, and it does also increase read query performance. Now, I just want to mention another thing here. I am using, you can see here, I'm obviously using a Databricks notebook. I am on my our solutions architect demo instance or cluster, but all of this could also be run on the community edition. So everything I'm showing you here today is in open source and could have been run on the community edition. It's just the community edition, as we all know, does run a little bit slow because it's a one node instance, and here I have 8 nodes, so this is much faster. So I want to show you 7 different things within this notebook. We're going to create those bronze, silver, and gold delta tables. I'm going to show you how we do have that support for batch and streaming into one table. I'm going to show you how we can do deletes and prove it to you that we can actually do that. I'm going to show you how we can update. I'm going to show you how we can do that schema enforcement and then that schema alteration. And then we're going to do just a little bit of time travel. So the data that I have here is a public data set from Lending Club. So what it is it's a set of funded loans from anywhere from between 2012 and 2017. So imagine it's things for like a home loan, home improvement, things like that. So it has the applicant's information, you know, like a user ID, their address, the state that they live in. Then the current state of the loan status. Is it current? Is it paid? Are they late on their loan? And then the latest payment information about that. So that's the data set. It's a public data set. You can pull it down yourself. So let's imagine that we are going to do, we're going to import our pre-bronze data. So imagine we're getting this data source maybe from another organization in our company or like a third party. And there are many small files, so they kind of remind us of, you know, like streaming or like highly transactional data. So some of these cells I've already run in advance. So in this case, what we're going to do is we're going to take all those files that we have that happen to be Parquet files, and we're going to read that into a data frame. And then from there, just because originally I was running this on Community Edition, it's a large data set, so I'm just going to randomly split that and just really par it down so it's pretty small. And then I'm just doing a small display here. So we've read it in, and now we have it in a data frame. So the next step I want to do is I want to create that bronze table, and I can do that really easily from a data frame. So I'm just going to pick a path here. And then, of course, if the path is already there, I want to remove it. And so I'm going to take my data frame here, which is loan stats. I'm going to write it in the format of Delta and save it to that path. And that's all I had to do was to take my data frame to a Delta table. In this case, it's going to be our bronze table. It's all our raw data. We haven't done anything to it yet. So let's now create that silver table. So in this particular case, we're going to create it from a temp table that we created from that parquet, from that data frame, pardon me. So we're going to perform some filtering on the bronze table to load it into a silver table. But let's just take a quick look at that schema in the bronze table. So I'm just using my data frame here just so I can just show you the columns. So you see there's actually, if I scroll through, we're not going to talk about each one of them. There's a lot of columns here, a lot of data. So we really need to filter this out for our silver table. Because so let's imagine we're the data engineer, right? And so our data scientists and our boss, actually, they want some very simple metrics on what we have here. So we're going to pare that down to just what they want to know. So what they want is the address state. So where the address of this loan is coming from, so be it California or Washington, and then the status of the loan. So what we're going to do is we're going to select those two columns, and we're going to do a group by and a count, and that's what we're going to put into our silver table. So we're going to create that table. So what we've done here, so we've taken that data frame, we've done the group by, we have a new data frame, and then we're going to create a temp table from that. And we're calling that loans by state. And then I'm just displaying it here. So we have our address state and the number of loans within that state. All right, so we've done quite a bit of filtering already. So next what I'm going to do is I'm going to create that silver path. And I'm going to create a silver delta table from a temp table. So we created our bronze delta table in a little bit different format than how we're going to do it right here. So this is actually using Spark SQL in this case. So I'm going to drop the table if it already exists. And you can see here, I'm going to create the table using delta with that location I set for my silver table as a select star from that temp table. So then I'm going to do a select star on the silver table, and you can see that here. So now we have that data in delta format in a silver table. And so I'm just going to do a describe details on that silver table, and you can see here right away, it gives us a lot of good information. The format is delta, the name of the loan, the loan's location in DBFS, created at, last modified, number of files, etc. All right, so now we're going to get to something a little bit interesting here. So in this case, I'm going to show you how we can do streaming in batch concurrent queries on one single table. So in the notebook, I'm going to do an insert every 10 seconds to our loans stats delta table. So I've already set up my streams here. And you can see I'm doing a select address state with the sum of the counts on that stream, or as loans from that loans by state stream and group by address state. So here's the current state of the table. Okay. So then what I want to do is I'm going to, I'm actually going to run this live, so let's hope for the best. So now I'm kicking off that insert. So as that insert starts to go into our delta table, we should see it update the stream as well. So if we come up here to our map, so I didn't talk to you about the insert statements. Let me scroll back down here. Our insert is going to be insert into our delta table, the values for Iowa, 450. So you saw above that Iowa doesn't seem to have any values. Iowa is actually null. There's no values. Nobody seems to have a loan in Iowa. Or we don't know anything about it since it's null. And you can see all the other values here. So here we should quickly see with our stream that it's updating, it's showing the updates from the delta table in this insert that we're doing here. So we should see it shown here in the map very soon. Once it turns color, it's going to get lighter, and we'll know that we can see it. So we know if I scroll down here, pardon all the scrolling, you can see, okay, it is inserting, so that's good. No, we didn't get any errors. But are we going to see our map update? All right, live demo here. Okay, well, let's keep going and scroll back because we should see it happen here soon. So I'm also going to kick off some other cells here, and I'm going to just run them all. Okay, let's scroll back up here. Yes, all right. We see it updated. Okay, wonderful. So now we see Iowa has 1,800 loans within that state. Okay, so that's awesome. So let's go ahead and just cancel our streams here. because now we've seen it, we've proved it to ourselves. Phew, and it worked. All right, so if I just now do, just a regular, I'm not running it on the streams, if I just do, and you're gonna see some error pop up, that's intentional, so don't get worried for me. So we should see that we got those updates on the Iowa table. That's from our Delta table, and our silver table at that. All right, so let's talk about a few more concepts around that. So I want to show you the updates, the deletes, and the merges. So in this particular case, in this cell, what I'm doing is I'm just creating, I'm creating a similar silver table, but in like a Spark SQL table or the Parquet format, not in Delta format. So that's what's happening here. And you can see I'm just showing that it's the same data. So I want to show you a delete support, because that's a pretty cool feature. So let's imagine, so we just did all those inserts into the Iowa table. So let's imagine that actually that's not what I wanted. That was wrong. So I want to do a delete on that. So I want to delete from that Parquet table that I just created, that Spark SQL table, where the state equals Iowa. So boom, you're seeing right away we had an error, and we have an error. So delete destination only supports Delta sources. So one, it proves what we already know about Parquet, that you can't do deletes on Parquet. Also, I just want to point out this really nice error message, because all the engineers here in the room, we have seen a lot of ugly error messages in our day, and this is not one of them. This is very clear what the problem is. So let's try that again with our Delta table. So I'm going to use the loans by state Delta, that's our silver table, and I'm going to delete from where address equals Iowa. Okay, so we didn't get an error, we got an okay. So if I come here and I do that same query, you'll see Iowa's back to null because we've deleted everything. All right, so now let's talk about some update support. So let's say I want to be able to update the state of Washington. I want to give that a count of 2,700. So here's my update statement. I'm going to do that on my Parquet Spark SQL table. And right away, you saw that was my error here. So now it's gone. Phew. Update destination only supports Delta sources. Okay, that's pretty clear. We know we can't do an update in Parquet without doing a whole lot of different things that we have to do to get that to happen. So let's try it with our Delta table. So we're going to update on our Delta table. We're going to exact same query. We see an OK. So if we do that, run that query again, we should see Washington has been updated. And Iowa is still with null. So let's talk a little bit about merge. So you can do a merge in Parquet. It's just kind of a very long and tedious process. So 7 different steps. We don't want to have to do that. So, I mean, probably many of you in the room have tried to do some updates on your Parquet file, and it was kind of a nightmare. So let's focus not on the nightmare and more on the dream. So with Delta Lake, it's really just a 2-step process. You have to identify the rows that you want to update, which is pretty obvious, right? And then you're going to use the merge. So in this cell here, that's exactly what we're doing. This is what we want to update. We want to put Iowa actually to 0 instead of null, California to 2,500, and Oregon to 0. So that's what we want to do. So we're just creating a little merge table based on that. And then here's the merge statement here. So merge into the loans by state Delta using our merge table where we have all those rows that we want to update, where there's state ID or address state matches. So when they match, update it, and when they're not matched, just go ahead and do an insert. So if we come back here and prove that that happened, we can see it very easily. So here's Iowa with 0 instead of null like before, and Oregon with 0. So let's talk a little bit about Schema Evolution. So that was something actually they mentioned in the keynote, a lot about dirty data, right? The schema's not, they're coming in, people are inserting, and it's not matching. And so that's fine initially when you just dump it into your data lake or your bronze table, but no one's going to be the wiser until you actually try to do something with that data, and it's going to cause an issue. So in this particular case, I'm just generating an amount. I'm saying, okay, so in Rhode Island, there's 21 different loans, and this is the amount that is owed to, our bank where we work, right? And so this amount is what my manager, my boss, that's what he wants to see. So I've added that column to my loans. I have a loans data frame here. I've added that column. So I'm going to just try to append that to my Delta table. And right away, we get a very clear error message, which I love. A schema mismatch detected when writing to the Delta table. Okay, so the command failed. That was our error here because the schema does not match the data of our original schema. So, right, we've already kind of talked about why this is good. So you don't want to have those issues of schema on reads. You'll see corruption, unpredictable results at runtime. So we don't want to fail at runtime. We want to fail now. We want to fail with that error. So in this case, what I'm going to do with that data frame, I'm going to do a write options, merge schema equals true. So it's essentially saying alter table. Alter table is fine. And format in the format of Delta, I want to append, and then I want to save it to my silver path. So we ran that, that worked. And so now if I do a select star on my silver table, you see exactly what we wanted. The address date, the count, and the amount. So let's create our final gold table that has all our finished aggregated data set. So we're going to create our path to our gold table. Then we're going to create the gold table using Delta with that path. And in this case, what we're going to do is we're just going to take the address state and the amount. Because now our manager, he only wants to see how much money is owed. He doesn't want to see the count of how many loans. He just wants to know the money. So that's going to be our gold table. So now we can actually just query that directly, and we can give that to our manager. So actually what we can do, I can do a select star from my gold table, amount, order by the amount in descending order, because he wants to know where the most loans are. And we can actually create a dashboard, which I created here. If it shows up nicely. There we go. So we can actually just send our manager this link, and they can just take a look at where the most amount of loans are owed. They see here in Washington State. And so then they're happy. They have that aggregated data that they wanted. All right, so let's just do one last thing here. So let's travel back in time. So I want to show you that you can do a describe history on that Delta table. And we can see all the actions that we've performed while we've been going through this demo. So here in version 9, you can see where the merge happened. 10, you can see where the write happened. And 8, you can see where that update happened, where we changed the Washington values. So let's say that we had an issue along the way. It's very easy to roll back to one of these versions. So I can also just do a select star from my Delta table, the silver table, version as of 0. So that takes us all the way back before we did anything. So essentially, that's like our bronze table, right? Because that was before we did anything to that silver table. And we can also do a select star from that Delta table as of version 8. So all the versions that we have available, we can do that. So not only can we do that by version, but you can also do that by timestamp, which I don't show you here. But you can also do it by timestamp, and you can also do it by a timestamp range, which is very useful. So that's the completion of the demo. So let's head back to the slides here. All right. So let's really connect the dots between what we've been talking about and what we saw in the demo. So we were talking earlier about what we were missing and what we wanted, right? We want the ability to read consistent data while the data is being written. So we want to be able to have snapshot isolation between writers and readers. We wanted the ability to read incrementally from a large table with good throughput. So we've optimized our file source with scalable metadata handling. We wanted the ability to roll back in case of a bad write, which we talked about quite a bit. And we have that ability with time travel. We want the ability to replay historical data along new data that arrives. And so we can stream and backfill historical data through the same pipeline. And then lastly, the ability to handle late arriving data without having to delay downstream processing. So we can stream in even late arriving data added to the table as they get added. So like we've been talking about this whole time, you can do that all with Delta Lake. So how do I use Delta Lake? So we did kind of see that a lot in the demo, but I just kind of want to break it down like just here to the basics. So just to use open source Delta, it's actually very easy. So you can easily add it to your Spark package. So if you're running a Spark shell command, you can see easily how you can, how you can add that with your package. And you can also add it as a dependency in Maven as well. And so when you have your data frame, normally if you're just writing in Parquet format, you do a write.format Parquet. Well, now, like we saw in the demo, all you have to do is dataframe.write.format of Delta. It's that easy. So you can build your own Delta Lake. Go to delta.io. And also just a little plug for joining the community, right? So we have a very active community around Delta, but we welcome more contributors. But another thing I want to mention, it's not just about contributing code, right? You can contribute to the community in a lot of different ways. So that's why I put up here like the Slack channel and the Google group. So just answering a question that somebody's asked is incredibly helpful to the community and really it makes you a part of the community. It makes you a very valuable part of the community. So while it's awesome to create a brand new feature and submit it, and that's great, and we want that, also just helping each other is just a really valuable way to help the community and help the project grow. And also we're on Twitter too, so if you want the latest news on the updates, so follow on Twitter. So the notebook, so like I said, you can run everything that you saw today on the community edition. So the notebook for download is there in that link. So when the slides come out, you can get that link. But also have a QR code to that demo as well. So if you take a picture, it'll take you right there. So, and don't forget to rate the session. And thank you all so much. I really enjoyed. I do have a few minutes here for a few questions. So I would love to answer those. Thank you.
So my question is, say you have this bronze, silver, and gold table. Would you then use different streaming jobs to get data from one to the other?
Yeah, I think that would probably be the best. Yeah, okay. Just using a different stream for each one. Yeah, for sure. Good question.
Thank you. Is there any kind of API to provide data instead of using Spark? For instance, to ingest data to the bronze versions?
So right now, the only APIs that are currently available are through Spark. But I know that there's, like I talked about with the community, I know that there's coming in some connections with Presto and things like that. And there may be future APIs in the future with the project. But right now, it's just via the Spark API.
Hello, great talk. First question about Schema Evolution. It is supported for adding new columns, right? Mm-hmm. How about deleting new columns? If you remove a column, let's say you are reading from Avro, from Kafka, mm-hmm. and there is less a column in the data frame, then it's on a target. It's Schema Evolution works, the merge that you showed, with removing a column. So this is the first question. The second question is about very low latency scenarios. Mm-hmm. So the Delta, bronze, silver, and gold, you are basically writing parquets over the architecture. So these introduce latency, right? So what's your recommendation for very low latency scenarios when you have like milliseconds from the reading to the sending something, again, to Kafka or other sources? Thank you.
Sure. So the first question around Schema Evolution on deletes. So I'm pretty confident that you can do that with an alter table. Yeah, but I don't, yeah, exactly. So I'm not quite sure when that's available, but I'm pretty sure that's coming here very shortly so that you will be able to do that. And number two, with the low latency from, source to, use, it's really something, of course it depends, and I hate saying that, especially as a solution architect, because we say that all the time, but it really does. But, you may want to evaluate that. Not every technology is good for every use case. So if you really need those low latencies, you might want to think about whether, for that particular job, whether Delta is the right, you'd want to test it out. But also I would add, what you could do is you could do a lot of your processing with Delta, and then you could actually send it off to somewhere that has like a lower latency, for those very fast queries, once you've done that processing. So that's an architecture you could consider. But if you really need it from ingestion to the end, you'd have to test it with Delta. Yeah, that's a valid concern though.
Thank you for the talk. My question is, as we can do time travel and see the previous versions of the data and then merge if necessary, can we actually see the delta, what has changed between these versions? For example, what was before merge and what would be after the merge?
Yeah, so there's not like a diff command that you could run. Maybe we should put a Jira in for that, because that sounds like a great idea. I think there's definitely a way you could do that with, running through SQL. I think you could definitely find a way, an easy enough way to get the diff. But there's not just a strict, like, what's the diff between version 8 and version 7? I think that's a great idea, though. Thanks.
Hello. I don't know how Delta works under the hood yet, but the question I have is, when I truncate the plan that Spark generates, by, for example, a checkpoint, does that impact the functionality of Delta in any way? For example, to see the data lineage or the schema modifications?
So the question is, is there any issue while you have multiple versions of the table, and does that affect your Spark queries from there?
No. For example, I'm reading in like data with a Spark job. I'm executing a lot of joins, etc., like through another function. I do a checkpoint or to local checkpoint where my logical plan gets truncated. Does that impact the functionality of Delta in any way?
That's a good question. Not that I've heard of. So, but I would need to check on that for you, because it's not something that's come up to my level, but that's something definitely to investigate.
Cool.
Yeah.
Thank you.
Yeah, sure. Thank you.
Okay, so very nice talk, Amanda, and thank you everyone for coming. Thank you.
Thank you.